Continuing our exercises, now we want to make the model that we had a three-dimensional. To do that, again, I'm going to make a new directory called delta03 and copy all the input files of delta02 there. Again, if I sort them by the date, whatever is after run ID is usually the input file that I need. So now I have delta 3 with the input files from the delta 2, and then I open my delta 3D and then select the directory. This time the directory that I want to work in is delta 3. I select this folder and then I open my input file, which is in this case the same thing as before. And now I want to change it to a three-dimensional model. I go to domain, I change this value to 5 layers. If you remember, you have done this before in previous videos as well. And now if I click here, it says that all the boundaries except water level will change. So I say, yeah, I understand that. And here we can see that we have 5 layers of 20% of the depth. But what I want to do here, I want to make the layers which are closer to bottom a bit finer and what is above the water a bit coarser. Again, we should be sure that the sum of all these percentages is of course 100%. So I have done that now. As it mentioned, there might be some boundaries with troubles. I'm going to look into them. So this is the current. I look at it. You can see that the currents are okay here. I go also to look at the water level. Harmonic, it is also what it used to be. This is also what it used to be, and this is also what it used to be. But I also look into the transport conditions here. Here we can see that the sand doesn't matter because it will override by the equilibrium condition that we have. I will look into the mud, but you can see that the mud has changed now. So I need to bring that back to 0. Close. I need to go to the west and also correct this back to 0, and then also to the north back to 0. And the river, the mud that we had in the river was of course 0.2, so I need to add that back here to have very similar models that as delta. You can see also something else opens here now. There is also possibility to define the vertical profile of the concentration in depth, because now in depth we have 5 layers. The choices that you have is uniform, linear, step, or you can also specify it by layer. So tell the model how much sediment comes in from which layer. But I will keep it uniform for now. And then I'm gonna go and save all and make sure that all my files are now saved. So this model is also ready, and I can close this and say start the model and let it run. Now you can see that this model takes much longer than before because now we have 5 layers also in depth. But again, also remember that maybe in the cases that you want to run, 5 layer may not be enough, and you may need to go to 10, 20 layers depending on the details that you need to simulate and need to observe. So I will keep this aside and go to exercise number 4. Now we want to also add salinity to our model. Again, I go and copy our last simulation with a new name. I make a new directory called delta04 04, and then I go to delta 3 that it is running and copy the input files to this directory. Now I have directory delta 04 and it is ready that I can add salinity and do the necessary changes. I come here, I change also my working directory now to delta 4, and now I open the flow input. And the first thing that I need to do is to go to processes and add salinity to the model. So that's the first step. And now I can see that I also need to do something in initial conditions. I'm assuming that the seawater is very saline, so 31 ppt with 31 ppt. So you can see it here that the water inside the model initially is 31 ppt. But I want to correct my boundaries now, because if I go to boundaries again and click on the edit transport condition, I should say yes to load that, and then say yes again, yes, yes, and yes, yes. And now everything is back here, but we can see that the salinity is also added here. Now we have salinity and both sediments. So I choose the salinity, and I am in the boundary of river, and of course I want to make the water that comes out of the river to the sea always 0. So very fresh water coming into the model. And then I say close and go to the north edit condition here. I want everywhere to be 31, 31, 31, and 31, because at the sea boundaries I don't want to have a gradient of salinity, of course. The same thing for the west, 31, 31, 31, and 31. Close, and south, the same thing. And because we don't have a tidal current or a lot of differences in time in the salinity at the boundaries, I keep the Thatcher Harleman time lag also 0. Now I go back here and save all the files that I have here. And now I can run this simulation as well. Say start, OK, and this new model is now also running. But you can see that because we have 3D and we added also another process, which is salinity, this model is taking the longest on my computer, about 1 hour 20 minutes. In the next videos, we will try to look into some of the results of these two models that we made and we are running now.